Okay, in this video we're going to be talking about geometric probability. Now probability, when we talk about probability, we're just going to be meaning how likely is it that something will happen. That's what probability means in general. And often when you're dealing with probabilities, this something is referred to as an event. And that's how we're going to often refer to, when we talk about probability, we're going to be talking about the probability that a particular event will happen. And when you write that down in kind of a formula way, we're going to write it like this. P, with this little parentheses, an event, that's the probability of an event happening, equals the number of ways that particular event can happen, divided by the total number of all possible outcomes. So this is kind of like a general formula for calculating probability. Now, we're going to be looking at geometric probabilities, which are using principles of length and area to calculate a probability. And in particular, we're going to be focusing on area probabilities. And area probabilities just means how likely is it that a point chosen at random from a whole area will be in a particular area. And the way we're going to express this using a formula is we're going to say the probability that a point is in a particular area, in other words, this is our event, the probability that a point is in a particular area is equal to that particular area, in other words, the value of that area, divided by the whole area. All right, so this is going to be the formula that we're going to use for these types of problems. So let's take a look at some examples on how we're going to use this formula. So example number 1 from your notes, it says, find the probability that a point chosen at random in this rectangle will also be in the square. All right, so if I randomly choose a point anywhere in this rectangle area, what's the probability that that point is going to turn out to be somewhere in this square? All right, so let's calculate that using our formula. So I'm going to first write down the probability that I'm looking for. And what I'm looking for, the probability that my point is in a particular area, I want to know the probability that my point is in the square. All right, so according to my formula, I can calculate that probability by finding the particular area here that I'm looking for. So since I'm looking for the probability the point is in the square, I want the area of the square. I'll just write that like capital A of square. So the area of the square divided by the whole area. Well, my whole area in this case is the area of that rectangle. So all I need to do is calculate the area of the square, calculate the area of the rectangle, and then divide them. Okay, so that shouldn't be hard. Area of the square, I know the area of the square is just side times side. So in this case, the side of my square is 3. So the area of my square is 9. I need the area of my rectangle. I know how to calculate the area of a rectangle. It's just base times height, so that's going to be 8 times 6, which is 48. Now I can calculate my probability. The probability that my point is in the square is the area of the square, which is 9, divided by the area of the rectangle, which is 48. And in general, we're going to express our probabilities as decimals, so if I punch that into my calculator, I get 0.1875. And that's the probability that a point chosen at random in the rectangle will also be in the square. Often you see probabilities expressed as a percentage. So this is technically a probability is expressed as a decimal. However, sometimes you see this expressed as a percentage, and you hear people talk about percent chance. So if I express this as a percentage, then I would say 18.75%. All right. Now let's take a look at part B of this example. Part B says, what's the probability that a point selected at random in the rectangle will be in the shaded area? Okay, well now I'm looking for the probability that my point is in not the square, but in the shaded area. All right, so if I write down my formula, now since I'm looking for the probability that the point is in the shaded area, I want the area of the shaded part. And I'm going to divide that by the whole area. My whole area is still the same. That's just the area of the rectangle. Well, I already have the area of the rectangle. That's 48. I just need to calculate the area of the shaded part? Well, the area of the shaded part is just going to be the area of the rectangle minus the area of the square. So area of the shaded part equals area of the rectangle minus the area of the square. And I've already calculated both of these values. The area of the rectangle is 48. The area of the square is 9. 48 minus 9 is 39. So now, to calculate my probability, the area of the shaded part is 39. The area of the rectangle is 48. And if I punch that into my calculator, I get 39 divided by 48, which is 0.8125. Or if you prefer to write that as a percent, 81.25%. And you may have noticed that there is a relationship between the probability that a point will be in the square and the probability that the point will be in the shaded region. And we're going to talk about that some more a little bit later. All right, let's take a look at example number 2. Example 2 says, find the probability that a point selected at random in the circle, this large circle, will be in the inner circle. Okay, so let's write down our probability. I want the probability that a point is going to be in the inner circle. And using my formula, probability that a point is in the inner circle, I need the area of the inner circle divided by my whole area. The whole area is the area of the, let's just say, big circle. So I can calculate this probability. All I need to do is calculate the area of the inner circle and the area of the big circle and divide them, and I'll have my probability. So, okay, area of the inner circle. Well, it's a circle, so that means I'm going to be calculating the area using the formula pi times the radius squared. And the radius of the inner circle is 6, so I've got pi times 6 squared, which is 36 pi. All right, so I've got the area of my inner circle. Now I need to calculate the area of my big circle. And the area of my big circle, again, is pi times radius squared. This time my radius is 10, so I'm going to be pi times 10 squared, which is 100 pi. And now I just need to divide those two numbers, the area of my inner circle. So I'm going to get my probability. It's the area of my inner circle, which is 36 pi, divided by the area of my big circle, which is 100 pi. My pi's cancel out. And 36 divided by 100 is 0.36. Or if you prefer to write that as a decimal, 36%. All right. Now, example 2b, it says find the probability that a point selected at random in the circle will be in the shaded area. So this one I'm going to leave for you to do, but once again, just like the example that we did with the rectangle, you need to first calculate this shaded area, and then you can divide that by the total area of the large circle. And we'll take a look at this example tomorrow in class.